Good morning, Geometry Honors students. So today it's Mr. Chen again. So I want to talk about that continuation with the two-column proof. So objective, right, simple two columns proofs. So definition, a theorem, it's a mathematical statement that can be proved. We talked about that already. So theorem 1, if two angles are right angles, they're always congruent angle. Theorem 2, if two angles are straight angle, then they're also congruent. Okay, so now let's look at that. The example with the fill in the blank for the missing reason. So given that the diagram as shown, prove that angle FGC, okay, so let's just highlight FGC, which this angle here looks like it's a straight angle. It's congruent to angle DGA, okay, so DGA, it's all the way over here. Okay, so that the diagram as shown, so this one, the first one, it's always considered a given. And then FGC, it's a straight angle. So this one, if that's a straight angle, so this one is using that theorem 2, the one that we mentioned about. Or this one, you probably want to just say that it's a definition of a straight angle instead of using that theorem 2. Definition of a straight angle. Okay, so the other one, DGA, it's also the definition of a straight angle. And then for number 4, step 4, the reason. So this one would be theorem 2. So going back to theorem 2. So if two angles are straight angle, then they're congruent. Another thing that I can put in here, I can say that the definition of congruent angle. Okay, so I'll put it right here. Definition of congruent angles. Okay, so now let's see what else that we have for the rest of this. So given that angle 1, it's 10 degrees, so 10 degrees. Angle 2 is 20 degrees. And angle 3, it's 60 degrees. So prove that angle ABC, it's a right angle. So basically we started out with the given. We write all those given information. Angle 1 is 10 degree, angle 2 equals 20 degree, angle 3, 60 degree. So all given. And then the next thing that you want to say here is that combine all those three angles together. So angle 1 plus angle 2 plus angle 3. So that equals 10 plus 20 plus 60. So this one, just say that it's substitution. Evaluate it. So this one, 10 plus 20 plus 60. Then that'll be considered a 90 degree. Okay, so this one you probably want to say that simplify. And then what we know is that once you combine them all together, so angle 1 plus angle 2 plus angle 3 equals 90 degree. So this one will be considered angle addition's postulates. Okay, so finally, the statement. So the final statement, so you want to state that angle ABC, it's a right angle. And this one is the definition of a right angle. Okay, so it's pretty basic, but you need to follow through that, the given. So once you start with the given, there's so many things that I can figure out. Combine those angles together, and then add them all together equal to 90 degree, and then using that angle addition postulate. Okay, so now let's see what else that we have. Excuse me. Okay, so given that angle 1, angle 1 is 4x plus 7. Angle 2, 2x. And we want to show that angle ABC is the same as angle D. Okay, so ABC. Okay, so this one, whatever that's given, so just rewrite all those information. X squared degree. And then angle D, AX minus 7. So one thing that we notice, angle 1 plus angle 2 equals angle ABC. So that's what we want to put in next. And the reason for that, angle addition postulate. And then after that, you want to plug in that expression of angle 1, angle 2. So 4x plus 7 plus 2x, so equals x squared. So this one, it's substitution property of equality. And then try to solve for x. So this one, I just want to get more space. So 4x plus 2x, so 6x plus 7 equals x squared. It's a quadratic equation, so you want to bring everything together to one side. So x squared minus 6x minus 7. And factor it, so we do have x minus 7, x plus 1. And this one we got x equals 7, x equals negative 1. But you got to be very careful, x cannot be negative because this angle could be negative. So this one, and then, so we just use that 7. So x equals 7. So solving for x here on the side, so we just solve for x. X equals 7. And then after that, so we want to plug in a number back to the measure of the angle. Okay. So statement and reason. So plug in the measure, plug in the value of x to that measure of angle ABC. So we got ABC equals 7 squared, so 49 degree. And also plug in that for angle D. We do have 8 times 7, which is 56 minus 7, 49 degree as well. So this one, probably want to state that it's a substitution properties of equality. And then after that, statement and reason. So just state that angle ABC is congruent to angle D. So this one will be going back to Theorem 1. If two angles are right angles, they're congruent. Well, this one cannot use Theorem 1. That's only for the right angle. So this one, just say that it's definition of congruent angle. Alright. Okay, so this one is just like formulas that you need to review. Okay. So make sure that angle 1, angle 2, once you combine them together, well, this one, we talked about that before. Whoops. So angle 1 plus angle 2. So it's always give you that the measure of the sum of those two angles, like angle ABC here. So here's angle 1, here's angle 2. So once you combine them, it's always the measure of angle ABC. Like that. And also the other one, it's like trisector. Okay. So trisector, so what we got here, so we got 1, 2, two different rates here with that angle. Again, ABC. So we got angle 1, angle 2, angle 3. So let's say that rate BD and rate BE trisects angle ABC. So that means angle 1 is the same as angle 2 is the same as angle 3. Alright, so this one is just like the extension of unit 2, which is 2.6, the two-column proof with regarding the angle relationship. So thank you for watching the video. So I'll see you guys next time.